pick this quarter. I can't believe we're at the end of the quarter already. That's craziness. Okay, so let's go back in the memory banks just for a minute to do a refresher of average rate of change. Remember our slope formula, okay? Rise over run and the change in, oh, what's wrong with those? M is equal to rise over run. Do you agree with that? Change in X over change in Y. That's a typo. We need change in Y over change in X. Which that can then, if we have 2 points, be found by y2 minus y1 over x2 minus x1. Okay, so let's find the slope through the following pairs of points. All right, which one do we want to be our x1, y1, and x2, y2? Isaac, pick one.
First one can be x1.
All right, so x1, and then that's x2. So, whoops, y. Having a little troubles there. Okay, so my slope is going to be 2 minus 3 over 4 minus. No? Question? Good? Which makes my slope 2 minus 1 is negative 1. 4 minus 2 is 2. So I have a slope of negative 1/2. Okay, still good with those? Remember that? Let's check another one. We'll do the same thing with the x1, y1. So I would have negative 3 minus 4 over negative 1 minus 3. Did I set that up right? Yes? All right, so then negative 3 minus 4 gives me a negative 7. Negative 1 minus 3 is negative 4. So my slope is going to be a positive 7/4. Good? What?
Why is it right?
Negative 3 minus 4. It's the two negatives make it positive. Yes? Are you with me? Why is which one negative? I did negative 3 minus the 4,
Okay.
then the negative 1 minus 3. Good? All right, awesome. All right, last one. I have 0 minus 4 over 2 minus 2, which gives me negative 4 over 0. What kind of slope does that make it? Undefined. Okay? Don't forget, if 0 is in the top of the fraction, then it's a 0 slope. Good? Okay. Average rate of change is kind of more applicable to your real life scenarios. The perfect example is miles per hour. Okay? When you're driving, your speed is basically the rate of change from distance A to distance B. We just calculate it in, because it's miles per hour. Okay? That's all speed is, the average rate of change. Okay, does that make sense? Okay, so when we find the slope of a linear function, we're just finding the average rate of change. Okay? So what we sometimes do is we want to say, okay, I have this graph here, and I want to know what my rate of change is from just a specific interval. Because it could be that I left my house and I drove to school, and then from school I went to the grocery store, and then from the grocery store I did another errand. I want to know just my rate of change from like school to the grocery store. That would be my interval, okay? So what we do is we look at that interval. So for like A, we want to know what it is from 0 to 3. So if here's 0 and here's 3, then we can just find my slope. So I'm going to count up 2, and then over 1, 2, 3, and negative 3. Good? Now I want to look at the interval from 3 to 6. So the interval this time I'm looking at is from here to here. And so do the same thing with your triangle. Just go up. It's kind of hard to see on this, isn't it? Yep. 1, 2. And when I go over 1, 2, 3, I'm going to have the same thing. All right, then the last one, I want from when x equals 0 to x equals 6. So from here to there. So if I count 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, negative 6, it reduces to the same slope. Okay, so over the different intervals, what do you notice? It's the same, right? Which means that if you have a linear function, then your average rate of change is going to be the same no matter where. I could pick points, like do an interval of, say, what's the slope going to be from 200, where x is 200 to x is 210. And it's not going to matter. It's going to be exact the same. Okay, because it's that line. That's the whole thing about the characteristics of linear equations. Okay? However, if it's nonlinear, like we have here, it's not going to be the same. Okay? But you can use the exact same method. Okay, so if I want to find the slope from 0 to 4, okay, here's 0. 1, 2, 3, 4 is going to be this point here. Okay? And what we're doing is, well, what's average? What's it mean when how do you find the average of something? You add everything up and divide by 2, right? That's kind of like what we're doing. We're finding the average, well, divide by the number of items you have, but in my thoughts, I'm doing 2 points. Okay? So, if we count up 1, 2, 3, 4, 5, 6, and then we're going over 1, 2, 3, 4. That means from that interval, from 0 to 4, my slope's going to be 3/2. Make sense so far? Okay, now I want to look at from the interval of 4 to 7. So that means I'm going to go from 1, 2, 3, 4, this point here, to 5, 6, 7, this point here. But I'm just going to do the exact same thing and use my rise over run. So I'm going to go up 2, 3, and over 1, 2, 3. So from 4 to 7 interval, I'm only going up an average of 1. Let's try this color. Actually, I probably need it this way. All right, now my last interval from 7 to 13. So here's 7, then 8, 9, 10, 11, 12, 13 is to this point. If I go up 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, over 5, 6, I have a point of 5, 6, or a slope of 5, 6. Okay? Now, some of the things, if it's a real life application kind of thing, let's use this at, say this is a graph of me driving my car. Okay? What could these slopes tell me about when I'm driving my car? Which is the fastest or the highest slope? Which number is the biggest? 3/2, 1, or 5, 6? 3/2, right? It's going up a lot faster. That's probably when I just start my car and I'm accelerating, right? I'm at the stoplight, pressing on the gas pedal, and I'm going. Okay? Now I have a slope of 1. That means that could be similar to I'm just cruising down the highway now. I've gotten up to the speed that I want to get to, and then I'm just going to drive. Then the last interval, even though it looks like it's going up rapidly, my average rate of change is 5, 6. Which means I actually kind of start slowing down because I'm less than the average rate of change of 1. Does that kind of make sense? Yes? No? You guys are not awake at all this morning. All right. Okay, so what we notice is that the different intervals had different slopes. Okay, and if we have a nonlinear function, it's going to have different average rate of changes over your intervals, depending on what you're doing. Okay, now the next one is, because we still have the same graph, okay, and so we had done from 0 to 4, so from 0 to 1, 2, 3, 4. We had used those 2 points, right? And we had come up with the average rate of change was 3/2, right? Okay. If we draw a line, oops, helps if you could see. If we draw a line between those two slopes, and use those points, we have 0, 1 for the first point, and oops, helps if I have the right one. And 4, 7 for the second point. Do you agree with that? Okay, so if we calculate the slope of this line using our slope formula, we're going to find 7 over 1 to 4 minus 0, which gives me 6/4, which, hey, is the same as the average rate of change that we computed. Make sense? All right, let's check the next point. All right, so we're at 0.47, and 4, 5, 6, 7. And at 7, we had a point of, let's see how many. Seven, 10. All right, let's draw our line. And if we use our slope formula, I'm going to have that 10 minus 7 over 7 minus 4, which gives me 3 over 3, which is exactly what we had computed on the front. All right, last one. I'm at 710, and I'm going to 13, 15. I have my straight line. Slope's going to set up to be 15 minus 10 over my x2 of 13 minus 7, which gives me 5, 6. And hey, that was exactly what we computed on the front with the rise over run. Easy peasy. Okay, only giving you 4 practice. Do the slope formula, do the rise over run, okay, draw your line between the two, and you're going to be good.